陈佑正，有这个人吗？没有。尹静薇，有这个人吗 ？No。我这个表大概是旧的表。陈学友。龚博洲，龚博洲，你为什么坐那后面？离我好远，听得懂吗？龚博洲点了2个大头，所以一定听得懂。有没有问题？我们现在做法就是把一些数学的解拿出来用，已经知道的解，怎么用？就是看它跟着边界条件的这个吻合度怎么样。OK， 所以呢，当这些解出来的时候，你必须想，就是这个解代表的是什么意义？我要 sin cosine 就是周期性的这个变化 ，sinh cos exponential 的话就是一路涨上去或一路跌下来。OK， 那有些呢会经过0，哪一个 sinh sin 会经过0。OK， 所以我们来看一个例子。Okay, two-dimensional problem is usually easier than three-dimensional problem. So let's assume that there's no variation along z. You only have variation along x and y. So therefore, now your electric potential only have 2 terms multiplying together. Okay, and so in the 3-dimensional problem, you have kx squared plus ky squared plus kz squared equal to 0. But for this 2-dimensional problem, in fact, you only have one eigenvalue. All right, kx squared, ky squared, the summation of these two equal to 0. So if you know kx, then you know ky. That's why I say that you have 2 symbols, but in fact you only have one variable. One variable. Okay, so you have this relationship kx squared plus ky squared equal to 0. Now, for the first solution, kx ky equal to 0, then you have a solution like this. Vxy equal to as plus b cx plus d, and these 2 terms multiply together. You notice that we have 4 unknown coefficients a, b, c, d. Okay, and you can figure out a, b, c, d from the boundary conditions. Okay, for the second case, suppose that the ks squared is larger than 0. We denote it with k squared. Therefore, your ky squared is equal to minus k squared. So in fact, you only have one eigenvalue, k. Okay, for this case, if you have a k is squared larger than 0, this means that you have cosine sine solution. Well, within the scope of this course, we deal with real values for the boundaries. So when you have a sine cosine solution, usually you do not spell it out into this expression. Okay. Later on, when you learn about wave, and they involve propagation of the wave, then you could use this kind of expression. But for the electric potential, the boundary conditions always give you real values. So you just pick up this solution only. Okay. But for the sinh and cos, this is a real expression. This is also a real expression. Sometimes you use this solution. Sometimes you use this solution. Okay. So for the second case, kx larger than 0, you have sine and cosine like this. And in the other dimension, ky along y direction, you have ky less than 0. So along y direction, you have cos and sinh. or sometimes you have to use this exponential minus ky and exponential ky. 你注意到之前这里是 kx， 这里是 ky， 因为这个的关系，这里都是用 k 了。后来在 y 的方向跟 x 方向都是用 k 了，就只有一个未知数而已。Okay, because this expression reduced the two variables into just one. Okay, so for this case, you have two possible solutions. And then for the third case, this value changed to less than 0. But ky now is larger than 0. So it's very straightforward for you to write down that along x direction you have cylindrical cosh or exponential. And along y direction you have periodical functions, sine and cosine. And which solution to use depends on the boundary conditions you are given. OK， 看你的边界条件。所以呢，我们很快拿一个这个例子出来。假设我要解一个问题，这里呢是 v 等于0，这里是 v 等于0，这里是 v 等于0。然后呢，你有一个这个electric potential vary with x along this boundary. So this is the Dirichlet boundary condition with all the electric potentials specified on the boundaries. OK， 然后呢，我们来观察一下，这从0到某些值，这从0回归到0，但是你知道这里头不可能是全部是0，因为呢这里是有值的，所以你一眼看下去，你知道怎么解了 ，right？ 你知道在沿的这个方向上头 ，it has to be a periodic function along x direction. Zhen Youxin, not here. Yu Haoxiang. Ooh, I have to update this list. 陈宏正，这个方向上头有个周期性函数，有没有问题？这个方向上头从0回到0，所以这一定是 sin 或 cos 的解。OK。你一旦选择这个方向上头是 sin 或 cos 的解，这个方向上头呢就是 cylindrical 或 cosh 或者是 exponential 的解了。Okay, so along the x direction, I have a sin cosine solution right here. Along this direction, I should have a cosh cylindrical solution or exponential minus kx exponential ky solution. Well, along this direction, along y direction, y, I could have another c prime exponential ky plus d prime exponential minus ky. This is also a possible solution along y direction. OK， 那至于要写下这个还是写下那个，我们来看一下它的其他边界条件的特性。OK。Well, the first boundary condition is that when x equal to 0, you have nothing. So this means that this solution has to go through the 0 point. It's a periodic function along x direction, but this function has to go through the 0 point because when x equal to 0, the potential is 0. So apparently this is sine solution. OK， 所以呢，我们只留下一个 sine 在这个地方，其他不管了。So this is a boundary condition. Well, the second boundary condition is that when y equal to 0, this has to be equal to 0. But when you check this, when y equal to 0, you cannot guarantee this expression equal to 0, except that this is equal to 0, this is equal to 0. Then everything is 0. So this is wrong. This expression is wrong. Okay, because when y equal to 0, when y equal to 0, the voltage is equal to 0. If you choose this expression, then everything is 0. So you cannot use this expression. So you just use this expression. And for this expression, when y equal to 0, this expression has to be equal to 0. This means that you have to pick up a solution that goes through the 0 point. This is cinch. OK， 所以呢，你这个边界条件让你呢，我下个边界条件让你只保留这个地方，但是在 x 方向上头，你还有另外一个边界条件。这个边界条件呢是 when x equal to a, the potential is equal to 0. So if you look at this, when x equal to a, no matter what the value of this y dependency is, you have to be equal to 0. So this means that the kx, ka, when y equal to kx, when x equal to a, has to be equal to m pi. M is an integer. 1, 2, 3 plus minus. Okay, so this means that your k, your eigenvalue can be obtained from this expression. Okay, 所以这个 k 这个值也被你找出来了，它是一个这么一个形式的值，然后 n 呢是一个整数。Okay, this is k, this is also k, so you can put it inside. And the third boundary condition, where you have y equal to 0, you have v equal to 0. So you basically just keep, wow, what happened? — 所以第三个边界条件基本上是告诉你说，你可以把 Cache 扔掉。Okay, because Cache does not go through the 0 point. And then you have this solution. Well, n is it's an integer. It can be 1, 2, 3, 4, 5, or even minus value. So any value of n will give you one solution. Okay, but if you put this into if you put this solution into the Laplace equation, any n value will give you a solution. So this means that you can do a superposition to write down a complete solution for this problem. Okay, you just run n from n equal to 1 to infinite. The minus value is not useful because your an is undetermined. Your an can be a minus value. Okay, so you don't have to run this from minus infinite to infinite. And n equal to 0 is not useful because if n equal to 0, basically you have nothing. Okay, so this is a complete solution. But at this point, we haven't used this boundary condition yet. 有4个边界条件，我们这还有一个边界条件还没用。OK， 这第4个边界条件呢 will be used to determine your an, your coefficient of an. But up to this point, do you have any question? 到这里为止有没有任何的问题？我基本上就是你已经知道一些数学家帮你解出来的解，你从里头挑。从观察，从这个边界的这个值来把这个未知的这些 coefficient 越来越少，让它们越来越少。OK， 到最后只剩下一个未知数。这个未知数呢，你从这里来解出来。OK， 要解这个未知数，我们必须把这个边界条件放进来。OK， 所以呢，这个当我把这个边界条件 y equal to b 放进来的话，我得到这么一个式子。 And the question is, how do I solve for an given this electric potential as a function of x？ 我们怎么去解它 ？OK， 在我们解之前呢，我们又要请数学家帮我们解这个，给我们一些这个hint。OK， 数学家说 ，Wow， 这些 harmonic functions， 这些式子叫做 harmonic functions， 周期性的。OK， 这些 harmonic functions 有些特性在里头。这个特性呢叫正交的特性。Well, if I multiply two sine functions together with different n and m and do an integration over half period a， 它们的周期呢是 2a，right？ 那这个如果积分过这个半个周期，然后这两个乘起来积分的话，它会等于0。If n not equal to m， okay？ But if n equal to m, it turns out that there's a value a over 2. Well, something happened to cosine. If you do this integration for this, the multiplication of these two terms with different n and m, it's going to be equal to 0. And if n equal to m, then this integration gives you a over 2. And you have done this before for the Fourier decomposition. 傅立叶分析里头你都学会这个，这个其实是傅立叶分析的一部分。那我们不谈傅立叶分析，我们把它叫做这个正交的特性 （orthogonality property of harmonic functions）。Well, this property will allow you to calculate the coefficient an. Suppose now, on the right-hand side you have f of x, right? And you know that this is the function valid between 0 and a. So you multiply both sides, 右边左边一个这么一个 harmonic function, and then integrate it from 0 to a. On the left-hand side, you have infinite sum, and you multiply this with a harmonic function sine n pi over ax and integrate x over 0 to a. This infinite sum is going to only give you one term where n equal to m. If n not equal to m, then the integration is going to give you 0. So this infinite sum can be dropped and keep this as n equal to m. Okay, and then you can deduce what an is. 这个去掉了，然后呢 n 等于 m， 其他的积分全部都是等于0。Got it, right? 看得出来吗？当然看得出来 ，right? 陈立昂看得出来嘛 ，right? 陈立昂聪明蛋，一看就知道。Yeah, 你有这个 orthogonality property， 所以呢，只有 n 等于 m 的这一项呢会激出东西出来，其他全部激不出来，因为 n 不等于 m 的话 ，n 不等于 m 的话，永远都等于0。Okay, so you drop this. So now you can do an integration of this. This integration gives you a over 2. 这个部分 a over 2. And then this sinh m pi b over a, because you are specifying the y equal to b boundary condition. So this y originally here is now is value of b. 你把 b 放进来了，然后呢，这个是 a over 2， 把这个整个除到那边来，你就得到你的 an 了。So this is the basically exactly the same as the Fourier decomposition you used before. Okay, so now you can determine the coefficient of an. 所以呢，这里任何一个这个 function f of x, you can derive the coefficient am in your infinite sum. So once you have am, you can put it back. You can put it back into this expression, to get your final solution. OK， 得到最后的解。没问题。底下应该是一个例子，我们来看。底下这个例子，现在呢，这个每个地方都有值了。前一个例子里头有一个边界上头，我们给一个未知的方程式 f of x。But for this problem, you have value everywhere, and for the top boundary and bottom boundary, you have electric potential equal to 0. And then at x equal to 0, you have a constant potential right here. And at infinite, for given finite amount of charge at the infinite, definitely the electric potential is going to drop to 0, right? 所以在这个例子里头呢，你很快可以写出一个 possible solution。在这个方向上头，从0到0，you know this time, the periodic function is going to be along y direction. So along y direction, you write down cosine and sine. This is very easy for you, right? Cosine, sine, cosine. 然后呢，这里呢就是 sinh cosh， 但是呢有可能是这个解 exponential kx exponential minus kx。你到底要写下哪一个？这个不难，因为 if you because you are calculating a region where the infinite location is included, the electric potential has to drop to 0. So therefore, along x direction, you can only have this term. Okay, you cannot even have this term. Because at x equal to infinite, this is going to go to 0. So very quickly you can sort of reduce those coefficients. Well, let's look at the first boundary condition, y equal to 0. When y equal to 0 is equal to 0, so you keep this sine ky into your expression. 所以把这个杠掉，你这里呢只有 sine ky。有加于，我一直念的话，你会不会觉得想睡觉？会吼，所以呢，我说偶尔要叫你。我这边界条件的话，基本上就是你观察，然后让这些 A、B、C、D 的这个项呢越来越少。OK， 所以第一个边界条件 C equal to 0 basically tells you that you have to use sine. Because it goes through the 0 point, sine 经过0点. Okay, so you keep sine right here. And the second boundary condition, because you include a location where x equal to infinite, so you have to drop this term. This is non-physical. When x equal to infinite, this is going to go to infinite. Okay, so you drop this term. So the whole thing is simplified to this. So now you use two boundary conditions, one right here to get your sine solution, and then another boundary condition is x at the infinite, so you get this exponential minus kx. You still have two boundary conditions. The other boundary condition is right here. This is another boundary condition give you the periodic function. So this is going to give you the eigenvalue. Okay, so the third boundary condition. The third boundary condition is going to give you a eigenvalue because at y equal to b, it has to be equal to 0. 所以当你把 b 这个 y 等于 b 带进来的时候 ，kb 必须是 m pi 的整数倍。Therefore, you have this eigenvalue, and any integer number of n is a solution. So you do an infinite sum to get you the complete solution. 跟前面一模一样。在这个 XYZ 坐标里头呢，我讲的特别慢，因为 later on, the next topic is going to be associated with a cylindrical coordinate system. You're going to deal with Bessel functions. The basic philosophy to solve the problem is going to be the same. So you better to get yourself familiar with the steps to get your solutions. OK， 所以在这里呢， 你跟刚刚一样 ，you end up having an infinite sum with an unknown coefficient. Now is the time to apply this boundary condition. 这个 boundary condition 告诉你说 well, if I have a y value between 0 and what and b, I have a constant voltage equal to v0. OK， 所以这时候呢，我们要开始做这个 infinite sum 的这个计算了。也就是说，把这个边界条件 y between 0 and b on the right hand side you have v0. So now you multiply both sides with sine kmy, and then do an integration from 0 to b. OK， 在这个式子里头，我们做一个积分。Let me do it for you. Now you want to determine this an. So let's multiply both sides with sine summation an equal to 1 to infinite. You have sine kn y multiplied with sine kmy, and then the whole thing do an integration dy from 0 to b, and on the right hand side you also have an integration of 0 to b v naught sine kmy, and then integrate over y. Okay, and because of orthogonality property of harmonic function, so basically you can cross this out, and then this has to be equal to n equal to m, n equal to m. Okay, and this integration is going to give you b over 2. So what you need to calculate is this. So let's do a calculation of this. This is equal to v naught km minus cosine km y. Y is from 0 to b. Okay, and you can do this calculation, right? Because this is going to be equal to what? 1 minus v naught. This km is equal to m pi over b, and then you have cosine m pi. So when m is equal to an even number, then this is 1. When m is equal to an odd number, this is equal to minus 1. OK， 所以这个的式子右手边这里你解出来了，在这里。左手边呢等于 am 乘上这个东西。So the final solution is am equal to this divided by 2 over b is your am. Okay, just put this into this square. You get a final answer. So this is sort of step-by-step solution for you. I hope that you can catch it. 有没有问题？有没有问题？廖碧涵，可以吗？我们交大来的，其实是你是香港来的，交换什么？兰州大学，好学校，我去过一次，很好的学校呀。他永远都是坐在最前面，没问题，所以我不需要叫他，因为他不会睡着。我叫会睡，还有谁会睡着？举手一下，我叫你。OK， 没有问题。啊哈， 这个你不想睡都会想睡，都会睡着。Cylindrical coordinate system， 啊，这个圆桌坐标之后呢，状况有点不太一样了。所以不太一样是数学式子不太一样，但是呢，基本观念是一样的。它的解里头也有 harmonic functions， 或者像是 harmonic functions。you can forget the harmonic function Cauchy for a moment. You understand that if you have for two-dimensional problem, okay, if you have a harmonic function along some direction, this means that you have periodic boundary conditions, right? And then in the other direction, you're going to have a field just grow up or just drop. And this is true no matter what kind of coordinate system you use. 即使用到这个球形坐标也是一样。如果是二维的问题的话呢，你有这个周期性的函数在一个方向上头，然后呢，这时候呢，你就涨上去或掉下来的这个函数呢，在另外一个方向上头。So you can think about that the situation is not so difficult. It's not so complicated. Even you work with the cylindrical coordinate system, you still have sort of two sets of solutions. One gives you periodical variation along one direction, and then the other one gives you monotonic growth or attenuation in the other direction. 所以呢，当你看到一些 spatial function 在这个式子里头的时候，不用害怕 ，OK。那些 spatial function 也有一些周期性的特性，或者是直接涨上去或直接掉下来的特性。So, in the cylindrical coordinate system, you have this Laplace equation. Well, 二维的总是比较可怕一点，我们先把它变成一维就好了。所以假设呢，第一个问题是 Well, if you have axial symmetry with longitudinal invariance, this means that the axial symmetry, this means that along z direction you don't have any variation, okay? No, axial symmetry. Axial symmetry means that you have axis, and then 在这个对于这一轴来讲呢，这个 phi 的方向上头没有变化 ，okay? So you have the partial derivative of v with respect to phi equal to 0. And also assume that along the z-axis direction, there's no variation. So you also drop this term. So basically, you take out this term and take out this term. 那这个问题有点像 coaxial cable 一样的问题。OK， 在这个 coaxial cable 里头呢，你有 r 方向上的变化。And then you have a quite familiar solution that is natural log. Right? If you still remember that last week we have a quiz asking you to calculate the electric potential, the voltage between these two conductors. This is RO, this is RI, and then suppose that you have line charge. Then the electric potential is like a rho L 2 pi epsilon naught natural log RO RI. Okay, you have this kind of electric potential. Therefore, you are seeing that there's a natural log right here. Well, now that we start the solution from the Laplace equation, so we have to find the boundary conditions. So suppose that you have a voltage V naught at the center, and then you have zero potential outside. OK， 那你有个通解在这里，这时候呢，你就把边界放进去。For r equal to a, you have v0. For r equal to b, you have zero potential. And again, two equations is going to give you two equations are going to allow you to solve for two variables, c1 and c2. So it's not a surprise that you get this result. OK， 有两个变数，你有两个边界条件，所以呢，你可以把这个 C1、C2 解出来，解出来之后，你得到一个这个你所熟悉的这个 electric potential 的式子。And this is the easiest solution from this Laplace equation in the cylindrical coordinate system, right? With axial symmetry and there's no variation along the longitudinal direction. 好，这是一维的问题，我们再继续把这个二维、三维加进来。这时候呢，你如果允许它在 phi 的方向上头有变化，又是老套，有两个这个二维，有两个变数的，这时候 let's do separation of variables， 老套 ，right？ 那你可以想见，这个其中一个解出来，会很像周期函数，另外一个呢会是涨上去或掉下来。哪一个会是周期函数 ？Well, definitely, this function of phi has to be a periodical function， 因为它是一个圆柱对称的系统 ，so phi of phi has to be a periodical function. So this R of R has to be a function going up or going down. 所以没有像刚刚那么复杂，你还要挑这个哪一个是周期性函数。In this system, this phi of phi has to be a periodical function. Okay, so with this separation of variables, you can separate them into two equations connected by an eigenvalue n. 这个 n 呢，在这里它是一个整数了。为什么？因为这个解一定是 sin 或 cosine. Okay, so immediately you have a solution. This phi of phi has to be equal to cosine n phi or sine n phi. N has to be an integer. So this is an easy solution, right? You don't have other choices. 在一个这个圆柱对称的系统里头，它沿的 phi 一定是周期性的，绕一圈又回到原点。所以呢，这个 R of R has to be a function going up or going down. 长得这个样子，所以不像刚刚有个这个在 XYZ 的系统里头 ，XY 的系统里头呢，你还得去猜说 X 方向是周期性还是不是周期性 ，Y 的方向是不是这个 Cauchy 性取，都不用猜了。R 的方向上头一定是这么一个解，然后呢 ，phi 的方向上头一定是一个周期性函数。Okay, but you have to look carefully that how you choose the solution for this one and for this one. Because if you involve a region of R equal to 0, you cannot pick up this solution. If R equal to 0 with minus n, then this term diverges. If you include a region where R is infinite, then you cannot use this solution because when you put R equal to infinite into this solution, this term diverges. So again, you have to decide which term you want to include based on the boundary conditions. And this is an R function, this is an even function. Okay, so the rule is that you should sort of reorganize the solution into two terms. One is associated with Rn and one is associated with R minus n. So if you include the region of R equal to 0, then you should abandon this solution. Okay, you end up having this expression. If you calculate the region where R equal to infinite is included, then you should just take out this term and use this solution. Okay, 所以这个跟 x y z 的这个坐标里头的这个解的方法呢，基本上是一样的，只是你会出现不同的这种形式。所以在这个例子里头 ，if phi start from 0 at this point, and this is v equal to v0, v equal to minus v0, and you know that this is 0 to pi, this is 0 to minus pi. So this is a R function. 也就是说，这个 phi 变号的话，这个 potential 也变号。So it's an R function. For R function, you don't need to use this cosine. you just pick up this sign solution. Therefore, you have this kind of R function solution. 所以在这个例子里头，你基本上在这个边界条件里头，你很快的把这个 cosine 拿掉。Okay, so the solution is like you use this one multiply with this, or you use this one and multiply with this, and want to know the electric potential everywhere inside this ball and outside, inside this cylinder and outside this cylinder. Okay, so number one, let's look at this. Well, I guess I want to leave this to Wednesday and look for questions from you. 有没有问题？有没有人要问问题？一定有，绝对有，打包票会有。哎，有没有人要问问题？你问了问题之后可以解救很多人哦，因为我们小考就不考了。Any question? Come on. 一定有问题，我的信心还没崩溃。讲到这里有没有问题？呀，是的。
老师可以问前一段时间的问题。
当然可以啊。
就是那个作业里面的。
你请坐。呀，作业里
就是那个电偶极子它那个位置，然后是指的是那个，它也给了一个坐标。00负2米，然后是指那个负荷还是正荷还是正荷之间的位置？
来，你说上一个作业是不是？这一次的作业。Good。这次的作业是我花了好多的力气想了老半天。Homework number 4。是第几题？第3题。Okay, the far field electric field and R from two dipole moment. 在2个不同位置。哪一个地方有问题？
是它那个坐标，那个00负2米或者那个003米，那个是电偶极子的那个2个电荷嘛？
对，中心位置。
它是中心位置。
对。因为2个这个电荷它的中心点的位置。OK，good， 这样的一个问题就可以解救大家了，解救大家。还有没有个问题？还没下课哎，请讲。你说，如果说这里不是接地，
对，是加 V0的话，为什么是中间求出一个，然后在旁边再是求出2个电荷，不是直接 Vm 等于 V0，然后直接等效负的
？Vm 等于 V0，因为你若放 good question。Okay, we'll go back to this problem. Q, if this is the connected with V naught, how do I put the image charge? 你说为什么不在这里？然后呢，设法算出这个上头的就等于 V0。这个会少一个变数，也就是说刚刚是 4 pi epsilon naught 1 qi ri plus q r equal to v naught。在这里头呢，你会没办法解出少了一个条件，没办法解出这个 Qi 跟 Q 的关系 ，Ri 跟 R 的关系。你如果要找出 R 跟 R 的关系，需要一个式子 ；Qi 跟 Q 的关系需要2个式子。OK， 所以你在这里头呢，比如说你把这个 Qi 放进来了，你把 Qi 放进来之后呢，你要决定这个整个等于一个 constant 的话呢，你 Ri 在变的话，你这里没办法是一个 constant value。OK， 你要整个是一个 constant value， 那你把 Qi 一放进来之后，设定某一个值好了，你会发现 Ri 一变，这个右手边也会跟着变。那你先放这个的好处在于就是，这个先满足了一个 v 等于0的边界条件在那个地方。OK， 这时候呢，这个条件就固定下来 ，Ri 摆了。然后这个 Qi 摆了 ，I 跟 R 的关系也固定下来的，然后呢，整个等于0。那这时候呢，你可以再写出一个式子出来，写出这个式子呢是4派 epsilon 0 1，然后呢再乘上一个第二个的 image charge， 让它等于 v。所以呢，你可以上下相加，不会影响到原来的解。但是呢，你若不这样做的话呢，你这里一下子放一个 v0的话，你这里放一个 v0的话，你会少一个条件去把 Ri 跟 Qi 一起找出来，因为在这个问题里头有2个变数。OK，good， 好问题，还没有打钟。剩下1分钟打钟，你如果问一个问题的话，我们就没有小考。
问之前问题。
可以啊。
我想问一下，那个第一的物理基地是什么？
第一。
对。
Good， 你的大名是什么？李博义。我要帮你们记住，第一位是谁？第一位是杜峰 ，OK， 好，然后李博义。第一的物理意是什么？第一well, let's look at the definition. The definition of D comes from this Gauss law. So the integration of D over surface is the charge, right? So if you have a field integrate over a surface, you're getting the flux, right? So this is the associated with the electric field. This is associated with electric field. So we call D as electric flux density. Okay, because this is a flux. So D basically is a flux divided by surface. And this is associated with the concept of electric field. So we call this electric field flux. This is a density. So we have electric flux density called D. And there could be additional physical meaning associated with D if we write down other equations. For example, if AN dot with D equal to rho S, this D in fact is equal to the surface density charge. Okay, so you can also interpret D as the density of charge on surface. And when we talk about time varying field, this D is called displacement current 因为之后呢，在讨论随时变的场的时候呢，这个项呢是相当于一个电流在空间里头，所以呢，这个 d 又有另外一个物理意义，叫做 displacement vector。OK， 将来你学时变场之后呢，这个 d 又叫做 displacement vector。那在目前呢，我们所学会的 d 就是 electric flux density。And the normal component of D along some conducting surface is the surface charge. 你们今天成功的让我呢不考小考，所以我do it next time. Okay.